Now we're going to look at the Vasicek model. The Vasicek model looks at the progression of interest rates. It uses mean reversion, which can also be used to predict the future long-term interest rates. And this is precisely what we're going to do here. We're going to try to predict these three trial values as accurately as possible. So we're going to predict our long-term mean, the speed of mean reversion, and volatility. This is the Vasicek model here. For the long-term mean interest rate, A here denotes the mean reversion, B is the long-term mean level, or is the interest rate at any specific point in time. And this section here represents the notion that when interest rates change, the speed of mean reversion will drive back the interest rate to its long-term mean. Sigma here denotes the standard deviation, and dz is the random element of the function, which incorporates any shocks to the series. So in order to find the three parameters here accurately, we start by getting our data set, which I've done for 6 years for the 1 month Fed funds rate. I express the Fed funds rate as in a decimal form. This column here just estimates the change between the current interest rate and the last period's interest rate. The column here is this section here of the function. It's the interest rate change with the speed mean reversion. This column here is the difference between the actual change in the interest rates and the one with the mean reversion. So now we want to select the values, these values here, that minimize this error here between the two estimations. We set out the probability density function by using the norms test function here in Excel. We include the error term here, and the value we're trying to minimize. We're trying to minimize the error. We set it to 0. We include standard deviation for the Vasicek model, and false for probability density function. So by running this function, we want to select parameter values that will bring us as close as possible to 0 on a normal distribution curve. So we want to try to get errors as close as possible to 0 while maximizing the parameter inputs here. To simplify the model, we get the natural logarithm of the probability density functions. So now to run the optimization and to find appropriate values for the parameters, we go to data, then we find solver, we select the value we want to maximize, which is the sum of the natural logarithm of the probability density function. We maximize, and these are the correct values, but I will show it again. So we go to solver, we maximize that value there by selecting these three values here, and we can set a constraint as well, because we want the volatility. We can't have a minus volatility, so we need it above 0. So we press solve. Yes, we keep the values, and so here it gives us the accurate and the optimal values for long-term mean, the speed of mean reversion, and the volatility.